Okay, thank you, Steve. Well, uh, first of all, as Steve mentioned, Semgrep is a static analysis tool. The goal is to find bugs and to find possible vulnerabilities in our code without actually running it. The name can be a little bit misleading. We know that grep is a tool to finding patterns in text using regular expressions, but Semgrep really works at a higher level. It uses tree to parse code, so it really has an understanding of the syntax of the code, not just plain text. And so this makes it a lot more easier. This makes it easier to generalize and to find more sophisticated patterns in our code. Um, so yeah, the semantic part doesn't really refer to interpretation. It really refers to the fact that it understands syntax. It understands some syntax equivalents. So that's basically just fancy speak for syntax sugar. And it has some understanding, some basic understanding of control flow and data flow. We'll see an example at the end of how that works. I want to emphasize that Semgrep is not the only static analysis tool that we should be using. Um, it's really well, it's somewhat limited in what it can do, but that's a trade-off, really. We are giving up some, um, let's say, some detailed view of our understanding of Julia for a more flexible tool. We'll see that Semrup can actually do a lot of things. It can serve as a linter, sort of as a formatter. So Semrup is really not about more sophisticated analysis. It's not a type checker. It's definitely not a formal verification tool. We can think of Semrup as static analysis in the small, or as a set of static tests that complement or hopefully the dynamic tests that we already have for our code base. So I'm going to show quickly here one of the first examples. So on the left, we have a Semgrep rule. Rules are written in a YAML file. In this case, this rule only has a single pattern. We're looking for global variable definitions. And on the right, we have a set of tests that we can use to check that this rule is actually working. In the pattern, we have here the $X. This isn't about expression interpolation in Julia. The $sign is used in Semgrep to denote meta variables. So yeah, it's a bit unfortunate that the meta language and the proper language share this syntax, but that's how it is. If we run the scan, we can see that it actually matches all of the examples that we gave it. Even the Unicode identifiers and the operators work just fine. So this would be really hard to do with a simpler tool like grep. And we can also see that here in the last example, it has as a substring basically something that resembles the first example, but it doesn't match because it's not syntactically the same. So that's roughly what Semrup can do. Here in the pattern, we have an ellipsis that just says, we don't care what's on the right-hand side of the assignment. This is what a typical Semrup workflow might look like. We would have our source files in a package, and we will run Semrup scan on those files. We can pass flags detailing the rules that we want to use with the config flag. So that can be a single rule or a several rules in a directory, and Semrup scan will return a set of findings. Well, in the CLI would print in plain text, but you can actually output more structure, a more structured format like XML or JSON. Okay, let's go back to the playground to show a second example. I think it's this one. Yeah, so this is another thing that Semrup can do. It can also serve as a smart formatter, I guess. Here we have a common pattern that's I guess it's really easy to make this mistake, to have an anonymous function and pass a single parameter to a function that isn't really necessary because functions are first called values in Julia. So we can actually ask Semgrep to fix this code for us. Here we have a map, we're applying the function, and if I call the autofix, it will show a diff of what that might look like. I can accept the fix. And here we have now that map only takes f as an argument. You can see the previous code comments that. We can run that again on the second example. And again, even though the name of the function is much more complicated, base equals, it works the same because it's just an identifier.
That's very cool. That's a really good example.
Yeah, I think, and this one is rather simple. Like Semgrep can do some interesting syntactic transformations for sure.
Yeah.
Okay, so we already saw how meta variables look. That's roughly the thing that you would use the most in patterns. And yeah, meta variables, I guess, are similar to capture groups in regular expressions, and the ellipses would be similar to like glob patterns or the star wildcard. But the really, really important thing about patterns is that they can be composed together. And we can have an algebra of patterns of sorts. So this, we can have some operations to build more complex patterns without actually writing more complicated code. We can actually go in the opposite direction. We can use regex-based patterns. So there are some things that the three-seater grammar doesn't care about. So like white space and comments. We can actually use regex-based patterns to check those things that exist at the text level. This is useful for formatting or maybe to enforce naming conventions of our identifiers. We could definitely use this to, for example, limit the Unicode characters that can be used in identifiers because Julia already has a very large set that it's allowed. And we can also have autofix rules that's the example that I just showed. Okay, so let's go to see an example of pattern composition. Okay, I don't care about this. Yeah. So now we have a rule that's a little bit more complicated. Here we have a pattern inside field that tells us that we only care about the subsequent patterns in a certain context, in this case, inside a function body. And now then we have an alternation, I guess. We could either have eval as a function or as a macro, and Semgrep will check for both. So what we're actually doing here is checking for eval inside function bodies.
Just to clarify one thing in the syntax there, if I recall YAML, it implicitly stringifies the values. Oh no, can you show me the example again?
Yeah, sorry.
So the quotes on line 10 are because the @ sign would cause something to be interpreted.
Yes, correctly.
Okay. You could put quotes around all the other stuff. You just don't have to because of YAML.
Yes, ideally for this single line patterns, it's better to have quotes. Like I could have.
It seems fine. Like seems fine not to. I'm not trying to call you out on this. I just wanted to.
Yeah, both work fine. In this case, the quotes definitely are mandatory for the @ sign.
Okay, thanks.
Where was I? Yeah, here on the test, we can see that Semgrep finds the eval calls inside the functions, but the eval on the top level scope works just fine because it doesn't match the first pattern. It's not inside a function body. We can add additional information to a rule to, uh, let's say, bring the rule into context. We can add a message. The previous examples had very short messages, but ideally you would have a longer message that explains what the actual problem with the pattern that we found is and some possible alternatives. Like the idea is to give the user some actionable items to, yeah, to be able to fix their code correctly. We can also add references. So most of the rules really are based on package documentation, base documentation, sorry, and style guides. And we can also add some metadata to relate the rule to lists of known security issues. So we have the OWASP list, which is a really broad uh, set of possible security issues, and the COE. I want to emphasize that point a little bit. So the common weakness enumeration is just a list of software weakness types. So it's more like a taxonomy of software weaknesses. It's a really general set of guidelines to, let's say, analyze the security of a code base. It's not meant to be about specific incidents. So there's a related list that you might have heard of, the common vulnerabilities and exposures. These CVEs are related to specific incidents and specific known bugs in existing packages. So we can think of CWEs as more a priori knowledge, things that uh, we should be using to prevent security issues. CVEs are just a list of things that have gone wrong in the past. Okay, let's look at one last example. This one is an actual rule that's in one of the repositories, and it's a bit more complicated than the previous ones, but it follows the same principles. The only new thing here is that we're using taint mode. So taint analysis in Semgrep is a way to keep track of untrusted data. We can have some sources that might bring the untrusted data into the program, and some sinks that are vulnerable functions. So in this case, our sources might be functions that read uh, anything really, or some HTTP method. So we're being really general here. It doesn't really matter. And our sinks do matter because they are file system functions, functions that take strings that are interpreted as paths. So here we have one of the meta variable regexes. So as I mentioned earlier, these patterns work at the lexical level. In this case, we're checking for the actual name of the identifier. Here we do care about the name, not just that it's a function. Yeah, this list is just, I think, all of the functions in the file system module that can take paths. If we run the scan, we can see that Semgrep matches all of the instances that are taking path as an argument, or that take some argument constructed with path. So interpolations are also tracked. But these calls below are actually using static paths. So these don't come from the same place, not from the read line. So they're fine. And Semgrep can keep track of the difference. Now we have a message that properly explains what the possible error is. A user might input special elements, special path elements to gain access to files that they're not supposed to. And we also have the metadata that I mentioned. We relate this rule to a single CLU, CLU22, that's precisely about these path transversal problems. We know that this rule has been the top 25 CLUs for a couple of years, so it's relatively relevant. And We also have an item, OWASP item. This broken access control is a really broad set of guidelines around injection attacks. So and accessing secure resources. References is, well, it's just the base documentation for file system functions. And the other things are just the license, the language, that in this case it's just Julia, and the sorority, which is just a word. Okay, our rule set is currently divided into 3 repositories.
Sorry, I have a. Can you go back to the previous example? I had a question about that. So, what happens? I imagine this doesn't get flagged, but I'm just trying to think of ways to foil this. If you define a function that calls maketemp on an argument, and then you call the argument, you call that function on, path that you read from read line or whatever, would that get flagged? I would imagine that's too indirect, but I don't know. I don't know how clever it is.
No, it would get flagged. So if I call make the of foo.
No. That's not. Sorry. What I'm saying is define a function called like foo, and inside of foo you call makedir. So let's say the function foo. This is going to be hard to code over, but say define function foo takes a path argument, calls
like
makedir on p. That's all it has to do. Okay, and then now after that, or before it actually, because that it could work, but yeah, you call foo on path. I guess the question is, does that get flagged?
Yes. So Semgrep does have some basic understanding of data flow across functions.
So does it flag makedir of p because it can't prove that p is safe, or is it because it was called later foo of path? If you delete the foo of path, is it okay?
I believe it is. Yeah, in this case it is.
Okay,
so yeah,
that's very impressive.
I forgot to mention something. Here, besides the pattern sources and sinks, we can also have a third kind of pattern that would be the sanitizers. So the sanitizers just, if you call a sanitizer on data that came from a source, then that data is now, let's say, clean, and passing it to a sink wouldn't cause Semgrep to report an issue. In this case, we don't have any sanitizer. I guess if we had like a path type constructor, we could use that as a sanitizer, but that also gets into the issue of how it actually work.
Perl has this whole taint idea going way back, and they basically say if you call if you match something against a regular expression, we assume that it you've cleaned it. That kind of thing could work, but seems a little ad hoc.
Yeah, I think it's better to only write the sanitizer if you're really sure that it will work.
Yeah.
So having like a safe constructor or something like that throws an error if the data isn't in the way that you want it to be. I would say that's the best way to ensure that the table is actually useful. So in this case, there's no guarantees around sanitizers, so there are none in the rule. Yeah.
Yeah, if I can just add, for this particular rule, we spent some time trying to figure out like how we would, sanitize it. And I think we looked at filepaths.jl as one possible recommended solution, but in this case, I think what folks would, ostensibly do is, do manual investigation or manual code review, and then actually just comment in their code semgrep okay. After manually looking at it.
Yeah, that seems like a good solution. The implicit thing, it's very hard to know like what functions actually sanitize something. I mean, I guess you could you could have, there could be situations where it makes sense, but I agree here. It seems like explicitly saying semgrep okay. So is that there's some syntax for that? There's like, you can have a comment that tells semgrep this is okay.
Yeah, I believe it's just
yeah, there
semgrep.
is. Sorry. Like in some formatting tools and some linting tools, you can add comments to your code base to signal to semgrep this is fine. But the idea is really to try to not do that. And the idea is that semgrep should just work on the code base. Obviously, if it's really important, yeah, for sure, you can add that to.
Well, I mean, there are situations where, like we're talking about, you read a path, then you do a bunch of logic to check that it's safe, and you do have to like use it for something with a file system. That's a viable thing to do. And the question is, how do you get semgrep to okay that? And I think it's reasonable to explicitly say semgrep okay in that situation. Like I did, you probably want to also put a comment in the code saying, like, I explain why you think it's safe. But yeah, for humans, that is.
Yeah, I know the comments work, but now that you mention it, I'm not really sure when you're using taint analysis if you should place the comment on the source or the sink. I should probably check on that because it's a good point. I hadn't really considered it. For the regular patterns, just placing the comment above, like here on the tests, this rule ID is just for the tests, but a similar comment works for the for ignoring patterns. Okay. Yeah. Any more questions about this rule? All right. Where was I? Yeah, we have a rule set divided into 3 repositories. The first one is a public repository, so really anyone can use that on their code. It's just some basic guidelines, some basic best practices. The second repository is really the one that's most complete, I would say. It has quite a few rules regarding security, so things like possible command injections, SQL injections, and that kind of stuff. And the third repository is much more recent. We created it because some of our clients, like Boeing, have much more strict guidelines and much more strict practices. So the idea is to have certain rules that apply in that context that might not be necessary in everyday Julia code. And yeah, between the last 2 repos, we have a coverage of around 23 CLUEs, most of them in the top 25. So there's quite a few things that we could do in the future. As I mentioned earlier, Semgrep is built on top of 3.0, so really any improvement to a 3.0 grammar is an improvement to Semgrep. The 3.0 grammar will already parse most of the code that you will write on an everyday basis, but I guess errors can be still hidden in more obscure code. We can also add more syntax equivalence cases to Semgrep. So that means if Semgrep is able to handle more syntax sugar, then writing rules becomes easier because you don't have to check so many patterns. So for example, we have to check, like currently we have to check arrow functions and regular function with blocks separately. They're not considered the same because one is anonymous and the other one isn't. If we could have them as being equivalent in some cases, then writing rules for functions would be easier. And yeah, finally, the final thing would be just to use Semgrep on real code, see which rules are actually useful, which rules are producing too much noise, and with that, we should be able to update the rules to make them more useful.